In this video, I'm going to explain how SMOTE-NC works. SMOTE-NC is a variation on the original SMOTE technique, and it can be used to fix class imbalance. An example of class imbalance is when your dataset contains 100 people, of which 3 people have a specific disease and 97 don't. Often the minority class is the class of interest, but if there is class imbalance, the learning algorithm will not learn much about the minority class. That's why you can create synthetic data points. You make fake people that also have the disease. Then you can have an equal amount of people in both classes. So SMOTE-NC is a synthetic data generation technique for imbalanced datasets with categorical features. The main challenge is then, how do we calculate the distance between points when there are categorical features present? So this is the dataset we're going to be working with. It contains 3 continuous variables and 1 categorical variable. The target variable says whether it's a minority or a majority point. The distance is then calculated by adding the median of standard deviations of all continuous features for the minority class to the Euclidean distance equation. And I will show you how to do that. This is what the data looks like right now if we don't include the categorical 1 variable. So step 1 is to compute the median of standard deviations of all continuous features for the minority class. So we first take the 3 values of the first feature of the minority class points. And we have a standard deviation of 52 there. For the second one, we have a standard deviation of 23. And for the third feature, we have a standard deviation of 15. The median of this is 23. Step 2 is, if the nominal features differ between a sample and its nearest neighbor, then this median is included in the Euclidean distance computation. So let's calculate the distances. As you can see, the distance starts off as a Euclidean distance computation. But at the end, we added 23, which was the median. This is because there is a difference in the categorical 1 values for I1 and I2. I1 has value A and I2 has value B. We do the same thing for I1 and I3. They also have a difference in cat1. And then we do the same thing for I2 and I3. However, here there is no difference in the value for categorical variable 1. They are both B, so as the distance is 0 between B and B, we do not include the median. So now we have calculated our distances. And we can start off by creating I8 right now. We do this by applying the normal SMOTE algorithm. We randomly pick a minority point. Let's take I2. Then we take its nearest neighbor, which in this case is clearly I3 with only a distance of 31. We subtract 200 from 177 and we do it times a random number between 0 and 1. In this case, I chose 0.7, but it could have been any number. We add 200 to that and we end up with 184. We do that for all 3 variables and we end up with the point 184, 56, 65. Now, of course, we still don't have a categorical 1 variable value. But this is what the data would look like right now if we do not include that variable. You can see that the new data point lies in between 2 minority points. Now we're going to calculate the value for categorical 1. First, we calculate the distance of the new data point to the other points. So from I8 to all others. We do this with the Euclidean distance. Note, the cat1 value does not exist yet for I8, so you cannot involve the median, because you only involve the median if they're different. That makes this a normal Euclidean distance computation. The difference between I8 and I1 is then 93, and we can calculate that for all of them. And we end up with this list. Step 2 is then, the nominal feature is given the value occurring in the majority of the k nearest neighbors. In this case, we said k is 1. The nearest neighbor of I8 is I3, because it only has a distance of 9. Categorical value of I3 is b, and that makes the categorical value of I8 also b. So now we calculated our synthetic data point.